All right, students, your lecture for today is Chapter 12, Section 1, and this is the third part of Chapter 12, Section 1. Chapter 12, Section 1 is a big section. It pretty much basically could be just simply 3 separate sections, but in the book, they include it all in one. So we're going to be on the third part today, and the third part today is adding and subtracting radicals. In other words, combining radical terms. Now, when I say the title Combining Radical Terms, many of you probably think to yourself, well, what is a radical term? A radical term is a term which contains a radical. Now, that definition may not help you much because you may not understand what is a radical. So let's go ahead and clear that up. A radical is another name for a square root. So in other words, what we're going to be doing today is combining terms that have square roots. So here we have an example of a radical term, 7 radical 11, or in other words, 7 times the square root of 11. That would be an example of a radical term. Now if you look at the heading of the lesson on that first slide I showed you, it said combining radical terms. Now when I said combining radical terms, many of you probably thought of combining like terms when we add and subtract. Well, combining radical terms is really very similar. Consider these two expressions below. Look at them. What do they have in common? What makes them different? Well, as you can see, what do they have in common? The 7s and the 3s. What do they have in different? One has the x's, one has the square root of 2. So in other words, you notice that the two expressions are really the same if x would be exchanged for the square root of 2. Now, when you add these two together, they're really doing pretty much the same thing. We all know that 7x plus 3x is equal to 10x. That's what we get when we combine like terms. Well, today we're focusing on adding and subtracting radicals. Well, adding and subtracting radicals is just like adding and subtracting like terms. You go ahead and you add or subtract the coefficient, or the number out front, and you keep the radicand the same, or in other words, the number inside the radical. So 7 square root of 2 plus 3 square root of 2 is equal to 10. You add the coefficients, and then, just like the variable stayed the same up above, the square root stays the same. So 7 radical 2 plus 3 radical 2 is equal to 10 radical 2. So as you can see, combining like radicals is very similar to combining like terms with addition and subtraction. So the key point we're trying to make here in the lesson is that the rules that apply to combining like terms also apply to combining like radicals. You add or subtract the coefficient, you leave the variable, or in our case today, the radical, the same. So if we go ahead and look at an example here, we have 9 radical 3 plus 2 radical 7 minus 4 radical 3 plus radical 7. Well, to simplify this, we got 9 radical 3 and we got negative 4 radical 3. If we combine those two, 9 and negative 4 combine to make 5, and the radical 3 stays the same. 2 radical 7 and radical 7 would combine to make 3 radical 7, because remember, radical 7 would be like 1 radical 7, and 2 plus 1 is 3. So as you can see, combining radical terms is just like combining like terms with addition and subtraction. Now, just like with like terms, we can only combine like terms if they have the same variable. For example, 3x plus 2y, that can't be simplified because they don't have the same variable. Well, just like with like terms, with like radicals, you can only combine them when the radicands are identical. So, for example, if I gave you the, let's give you 5 radical 2 plus 6 radical 3. You cannot combine those two because they don't have like radicands. Remember, the radicand is the number inside the radical symbol, or in other words, the number inside the square root symbol. So 5 radical 2 plus 6 radical 3 can't be simplified because they don't have the same radicand. So a key vocabulary term that you may want to put in your notes if you don't have it down yet is that the radicand is the number underneath the square root sign. And in order to be able to combine radicals, you must have like radicands. When 2 or more terms have exactly the same radicand, we call them like radical terms. And whenever we have like radical terms, we can go ahead and combine them. So for example, 4 radical n minus 6 radical n would equal negative 2, because 4 minus 6 is negative 2, and then our radicand stays the same. So it would be negative 2 radical n, or negative 2 square root of n. And just as we explained earlier, when the radicands are not identical, the terms cannot be combined. So 2 radical 7 plus 3 radical 6 is just simply 2 radical 7 plus 3 radical 6. It cannot be simplified. Let's go ahead and get some practice combining radical terms. These would be good examples to put down in your notes. First example, 4 radical 5 minus 5 radical 5. Here we have like radicand, so we can combine these two. 4 minus 5 is negative 1, and then the radicand stays the same. So my answer is negative 1 radical 5. Example number 2. Now I remind you, if I'm going too fast here, push pause, write the example down, then push play again. Use that pause button. Example number 2, we got 3 radical 2 plus 9 radical 3 minus 6 radical 2. Here we have like terms. We have like radicals. We have 3 radical 2 and negative 6 radical 2. If we combine those two, we get negative 3 radical 2. So my final answer would be negative 3 radical 2 plus 9 radical 3. Okay, this answer is simplified. Can't go any further. Alright, a couple more examples and then we will be done with our teaching here for this evening. Here I want to get into practice combining radical terms when they don't appear to be the same radical. Now many of you would look at this and say, oh, it's simplified because there's not any like radicals. Well, you must be careful of that statement. In order to determine if we have like radicals, we have to have all of the radical terms simplified. So as you can see here, these radical terms are not simplified. If you look at radical 12 and radical 27, those contain perfect squares. So let's go ahead and simplify them down. 3 radical 12, if you were to simplify it, would actually simplify down to be 3 times radical 2 times 2 times 3. And then that could be further simplified because you have a pair of 2's. So the 2 could come out, and when the 2 comes out, that would leave you with 6 radical 3. So if we simplified that, we'd have 6 radical 3. Now do we have like terms that can be combined? Yes, we do. Let's go ahead and also simplify 6 radical 27. Now some of you might be thinking, well, why doesn't he simplify the middle term? Well, the middle term is already simplified because the only thing left inside the square root symbol is the number 3. 3 doesn't contain any perfect squares. So 6 radical 27 could be simplified to be 6 times 3 times 3 times 3. So what's going to come out of there? A pair of 3's, so that's going to become negative 18 radical 3. Now this can be further simplified here. 6 radical 3 plus 9 radical 3 would be 15 radical 3, and then minus 18 radical 3 would be negative 3 radical 3. So always be on the lookout for like radicals. It may not look like they're like radicals. So before you make the decision that, hey, this can't be simplified, make sure each radical is simplified. Then if it's simplified and you don't have like radicand, you're done. But always make sure it's simplified first before making that decision. Alright, Titans, that's our lesson here for tonight. Once again, if I went too fast, pause it, rewind it. Okay, do what you need to do to make sure you get all the information. Or even maybe watch it again if needed. Thank you for tuning in tonight. Hopefully you took some good notes, and hopefully you can come in tomorrow ready to practice Chapter 12, Section 1, Part 3, Adding and Subtracting Radicals.
Made with Doodlecast Pro.